Right, so now I want to start by looking at how we use the tangent ratio. So you'll want to make sure you have a calculator handy, a scientific calculator that has the sine, cos, tan buttons on it. We will need that. And so we're going to start just by looking at this set of triangles here. So I've got the large triangle A, B, C. Notice that C is a right angle. A is 31 degrees. And so B we could calculate using the 180 degree rule. Notice that in the next triangle, AED, we also have a right angle. So angle D must be the same as angle B is the same as angle F because they all have this other angle of 31 degrees shared. And what we're comparing first is the length of FG in the small triangle, this, which is 3, to AG, which is 5. So, if I write this as a decimal, 3 over 5, is it like a 3 over 5 is 0.6. So what about DE now? This one, that height of the triangle to the ratio of the base is 10, 6/10. Well, that's also 6/10. And then BC over here to AC is 24 to 40, which is also 0.6. So we notice that the ratio of the opposite side, so notice that in these triangles, if I clean this up a little bit for a moment, that from the angle at 31, this is its opposite side. So is this, and so is that in the large triangle. So the ratio of the opposite side to the adjacent side, and the adjacent side, I mean down here, the base, right, compared to the height in this orientation, is the same, provided that the angle remains the same. And the angle is the same. It's 31 degrees in all of them. So that ratio is what we call the tangent. And we write it like this. So the tangent of an angle is defined as the ratio. So tan of A, where A is the angle, is the opposite side length divided by the adjacent side length. So down here, I've asked you to find tangent of P. So the tangent of P is its opposite side length, which is 5. If I go out from the angle, I hit 5, so that's the opposite. And now the adjacent is a little bit trickier, but remember, each acute angle is made up of 2 lines. One of them is the hypotenuse, and the other is the adjacent. Okay, so the tangent of P is 5/8. As a decimal, that's 0.625. All right, and then if I turn my attention up to tangent of Q, the other acute angle, now up here, this is a little bit different. Tangent of Q, its opposite is 8, and its adjacent is 5. So this is actually 1.6, the tangent of Q. So these are reciprocals of each other. And now you might say, well, who cares? What does the tangent get me? How can that help me? Well, this is where you want to have your calculator handy. If I know that the tangent of P, for example, is 5/8, I want to get rid of this tangent somehow and figure out, well, what's P equal to? So to do that, I need to take what's called the inverse tangent of both sides. So I'm going to go inverse tangent of P, and these two undo each other. Just like, say, squaring something and taking the root undo each other and just give me x. They're inverse processes. Anyway, what I do to one side, I do to the other. So in my calculator, I'm going to put in either shift or second function or whatever it is on your calculator, tangent of 5 over 8, and that is going to give me 32 degrees. And that's the size of angle P. If I use Q now, I could do the same thing. Tangent of Q is 8 over 5. So that means Q is the inverse tangent of 8 on 5 is 58 degrees. Okay, now if we turn our attention to this second triangle over here, tan of Q is its opposite. So if I'm up here, my opposite is going to be 2 over the adjacent, and I don't have the adjacent. So this is where I go back to my previous knowledge about trigonometry, and I have to calculate, using Pythagoras, the length of this side here, side P. So P squared is 7 squared minus 2 squared, yada, yada, yada. P turns out to be 6.7. So I'm going to put that in here. And now I can actually figure out the size of this angle using, again, the inverse tangent ratio. And let me get rid of this. We're going to do also the tangent of P, which would be 6.7 down here now, its opposite side over its adjacent side. And if I do the inverse tangent of that, that's going to give me angle P, which is 73.4 degrees. Okay, down here, why don't you try this one? What is the tangent of E, right? So that's just the ratio, not the angle yet. What is this fraction here? And then I do the inverse tangent of that ratio to figure out what E is. Do the same thing for D and see, does it work out? Do the three angles add up to 180 degrees? Okay. All right, if you did that, hopefully you found that E is 49.4 and D was 40.6. If you had those backwards, then you mislabeled the opposite and adjacent. Okay, so we have a few other questions we're going to look at. Here, same thing. So again, you might, if you didn't get that first one right, you might want to pause it here and see this one. Angle D, tan of D is opposite over its adjacent. Remember, this down here is the hypotenuse, so I don't care about that when I'm doing a tangent calculation. So D is the inverse tangent of 3 on 15, which gives me 11.3 degrees. So this triangle isn't really drawn very well to scale. If this is 3, this side that's 15 should be much larger, but anyway, there you have it. And now I could use, say, to find angle E, instead of doing a tangent calculation, I could do 180 minus my 90 degree angle minus angle D, and that would give me 78.7 degrees. And that's another way I can determine that length. Okay, now we have a couple of problems to look at. In a park, a slide is, okay, well, let's draw our slide. So, oops. Here we'd have the ladder going up to the slide, and then here's the slide. And you can see that I have a right triangle right here. And it says the slide is 198. Well, that's this part. That's the hypotenuse. The stairs are 120. Determine the angle of inclination. So remember what angle of inclination means. It means from a horizontal line upwards. So where's that in our diagram? It's right here. So if I want to find that angle, which I'll just call A, the tangent of A is its opposite, which is 120, but I don't have the adjacent. So I have to do a really quick Pythagoras calculation to find that base. I'm going to call that the base. And if I do that, it turns out to be 157.5. So I'm going to put that into the calculation, and I do the inverse tangent of that ratio. And it turns out that A is 37.3 degrees, and that's the angle of inclination of that slide. this says that the tangent of one of the acute angles in a right triangle is 5 over 5. So let's go back to our definition of tangent. The tan of an angle is the opposite side length over the adjacent side length. And in this case, it turns out to be 5 over 5. So let's draw that. Let's call this angle A. Its opposite is 5, and its adjacent is 5. So what does that tell me about this triangle? Well, it tells me it's an isosceles right triangle. And so if this length and this length are the same, then another thing that happens is that this angle down here must be the same as this one here. Okay, or if you don't see that right away, if I know that the tan of A is 5 over 5 or 1 over 1 or 7 over 7 or whatever that turns out to be 1, if I do the inverse tangent of 1 to find A, it turns out to be 45 degrees. So this is 45 degrees, and so is that. Because remember, the sum of the angles is 180. If I take away the right angle, that leaves me with 90. And if I divide that by 2, I get 45 degrees, which are those two angles. So here, what conclusion can you make when the tangent of A equals 1? So if the tangent is 1, then that means A is 45 degrees. We just saw that. That happened up here. That's when the opposite and adjacent are the same length, be it 5 over 5 or other number, right, some other number over itself. If the tangent of A is less than 1, what does that mean? It means that A is less than 45. It means, for example, if I draw a really small angle like this, and I call this angle A, and you can see this is much smaller than 45. This might be something like 2, and this might be something like 10. So my ratio, my tangent is 2/10, which is less than 1. That means my angle is less than 45. And if tangent of A is greater than 1, imagine if I flip that around, and now I draw a triangle where the angle is much bigger than 45 here, and this is something like, say, 8, and this is something like 5. Now 8 over 5, the opposite over the adjacent, 8 over 5, well, that's bigger than 1, so that means angle A is bigger than 45 degrees. Okay, and that is the tangent ratio.